all from you and let me miss her because we're recording this.
Hi, Maddie. I love you, Cookie Bear. I love you, Cookie Bear.
Okay, we love you, Maddie. We miss you. You better be watching this. All right. Hey, boys. And a hush fell over the crowd. It's like good night moon.
I love that.
I know, I love it. Okay, guys.
Like that question from.
Oh, I didn't do it.
Read that.
Oh, yeah, we do need to go over that crazy homework question, right?
Oh,
Did I tell you we were going to go over that crazy homework question?
Yeah, you emailed them.
I emailed you guys yesterday? I give them all the time. It's like crazy. All right, where's my Yes, okay, everybody open number 2. Everybody open your homework 3.1, number 2. This one was really tricky and I want to go over it with you guys. Did anybody? Yeah.
If, like, when we're done with the lesson, you said you'd go over them to an email, but I have a question on 9 and 10.
You have questions on what?
9 and 10.
9 and 10 on it also?
Yeah, I was gonna say, when you're done with this, can we do that? Like, how long does
That's a good idea. Hey guys, here's the deal. And a hush fell over the crowd. Zach, a hush. Owen, the hush.
Oh, my bad.
So here's what we're gonna do. We do have a couple of questions on the homework. Let's go through the lesson first. We'll use the rest of the period for homework time. If we run out of time, don't worry about the due date being tomorrow. You guys can come in at lunch tomorrow, the second half of lunch if you have extra questions. Just don't worry about the due date. I will count it late. Okay, so let's go ahead and go through the lesson first, and then we'll worry about those homework questions. Okay. So we're still working on transformations. Yesterday, what transformation did we work on? Was that? No, we didn't work on dilation. We worked on reflection. Very good. Now, did we represent? As long as I can reach, that's fine with me. Remember that? Did I press record? Is it recording? Yeah. Okay. Can you put that away for me? Get your notebook out. Okay. Are you making sure you're in there to verify that you belong in this school?
Yeah.
Okay.
I would set it.
Okay, you said double check. Does it say not pictured?
Yeah, I'm not.
All right.
I mean, this is, it like says my name, but it's just a blue background.
Oh, okay. Undercover. Incognito. All right. So yesterday we talked about reflections. Today we're talking about translations. A translation is just basically when it shifts or moves somewhere else. Now you tell me, is a translation rigid motion or not rigid motion? Think of what rigid motion meant yesterday. What did rigid motion mean?
Keeps the same length.
What's that?
Keeps the same length.
Same lengths and same angle measures, right? So a translation is basically taking that shape and moving it to a different location. Is that going to preserve the lengths and angles?
Yes.
Yes. So is it rigid motion?
Yes.
Yes. All right. So a translation is a transformation in a plane that maps all points of a pre-image the same distance and the same direction. So all points are going to do the exact same thing. They're not going to go in different directions. They're all going to go in the same directions, which is why it ends up being rigid motion. The translation of this triangle ABC by x units along the x-axis and by y units along the y-axis, they're just giving a variable instead of saying they're going by 5 units and 3 units, they're just saying an x number of units and a y number of units, can be written as capital T for translation And then our x and our y represent what? What do the x and the y represent in these little parentheses, these little baby x and y? What's that? Yeah, how much it's moving, either left or right, and how much it's moving up or down, depending on if it's positive or a negative number, right? Does that make sense? Can I get everybody's focus up here? I'm seeing eyes like all around, okay? Raise your hand if you need me to repeat that about what x and y stand for. Is that everybody good?
Yeah.
Okay, so the way, remember we talked about how like the fancy notation of when we were writing reflections? Well, this is the fancy notation of writing a transformation. So it'd be capital T, and then in a little baby parentheses down here with your x and y, those are your numbers representing which direction it's moving. Then we say the translation x and y of triangle ABC is or equals triangle A prime, B prime, C prime. Which one's the pre-image and which one's the image? The pre-image is triangle ABC, and the image is triangle.
A prime, B prime, C.
Very good. So a translation has the following properties. If translation of the translation xy of the triangle, then the distance between A and A prime, the distance between A and A prime, that line, is what? What is this notation? Parallel to the distance of B to B prime, and it's also parallel to the distance of C to C prime. You guys get that?
Yeah.
Then we also have A to A prime is equivalent to B to B prime and C to C prime, because they're all moving the same distance away from the original image, the pre-image. You guys good? Okay. So what is the graph of this translation? Well, let's look at the pre-image, which is the one that's written in black. It says the translation 7, -4. What does that mean we need to do?
Right 7, down 4.
To the right 7, down 4 for each point, right? So, to the right 7, 1, 2, 3, 4, 5, 6, 7, and down 4, 1, 2, 3, 4, will get you from E to E prime. Same exact thing for all of the other points on that triangle. Right?
Yes.
Easy, right? Can we kind of move along?
Yes. It's light.
Yeah. Oh, what'd you say?
It's light.
It's light?
Yeah.
Oh, okay, is that like a new term I haven't
Yeah.
learned yet? Okay.
It is. Who's mine?
So this little subscript indicates that each point is moving 7 units to the right and 4 units down. We just said that. Find the coordinates of the vertices of the image, then plot the points and draw. Notice that when I kind of showed you on the graph, I was kind of like counting along the units. But really, what we're doing is just, okay, so the point for E, where I was counting, the point is -5, +4, right? Even without counting on this coordinate plane, I could simply add 7 and subtract 4 on my x and y, respectively. First add 7 to the x, and then subtract 4 to the y, and that will give you your E prime location. So you can actually find your new location of the point without counting it on the coordinate plane. Does that make sense?
Yeah.
And we could do that for each of these points. Add 7, take away 4. Remember your, I know you guys know this, but your rules for adding and subtracting integers, and just make sure that your math is correct, and you can do it without actually drawing. Or without actually counting, and then, once you get your new coordinates, you can simply plot those points, connect the dots, and you've got the triangle of the image. We good?
Yeah.
Great. Okay. You guys do this. What are the vertices of triangle E prime, F prime, G prime for each of these translations? So, we're gonna have to go back to the original, right? So write these down. Actually, what I'll do is I'll write down these points here. So the pre-image, E was -5, 4, F is -1, 5, and G is -2, -1. So go ahead and do A and B. I'll write the answers down. Algebra book. Can you grab me the example? You're doing A and B.
What math? I wrote some of them.
Yeah, I know, I was just thinking that. Once you get them, Jared's gonna come around and check.
This is a very crowded classroom.
I'm making my way.
He's finding stuff.
He's finding
Because -5 was -1.
Wow, perfect. Good job. How do you do this? Here, let me take it. Right Okay, perfect. Okay, basically, for this, you're taking the coordinates, okay, the ones that you wrote on the board, and then you're applying the differences. So the first one for A is 6, -7. You can basically just add the x coordinates and add the y coordinates. So if you were translating E, okay, -5 and you were going 6 to the right, using that, it's -5 plus 6. 1, perfect, and then what's 4 minus 7? Or do you get what I'm doing? Do you get what I'm doing here? You're basically just adding or subtracting whatever the numbers that you give for each one.
Can you explain that to me? Can you explain that to me?
I'm gonna just explain to the whole class real quick, just so we can catch up. Real quick, everybody. What we're doing here is our little subscript here is saying for each of these pre-image points, add 6 to your x. Subtract 7 from your y, or add a -7, technically. Add a -7 to your y. That's how you will get your E prime, F prime, and G prime. Do the exact same thing for part B. Add 11 to your x values, add 2 to your y values. Do you guys understand? Okay. Raise your hand if you need help, or if you want to check your answers.
It's like suspicious.
It is suspiciously easy, it's just, you actually have to do
I
it
just
though.
didn't know.
But now you do, so you can do it. Go ahead and do it. Do it.
Just show on the road.
For real, for real.
Okay.
You want to trust my answers more?
Yeah.
I'll trust yours than mine. Me,
You know that?
did I realize?
Yeah.
Yeah.
We're going to go great. Look at that.
No,
I know, I'm surprised. It's just like, time consuming, but easy.
Wait, Raina, you added negatives and positives?
I know,
right?
it's crazy. I don't know integers at all. Me neither.
Are we doing okay? You guys done?
Yeah.
I'm almost done.
Should I check your answers?
I thought it was like, if you're.
You sure? The top one is A.
I don't understand what's recording,
Oh, yeah, I did that. Forgot it was two.
I'm not in
Wait. Oh, yeah. That was doing 15. Yeah, you can-
Hayden, did you get them? You got it.
Have you tried my answers total of each letter? Or you could once you find the
I can't hear you.
once you find the coordinate of each letter, what do you do?
That's it, baby. You got your prime. You don't have to complicate. That's it, baby. I say it. I say things that you're saying. That's what makes
Do you want to?
All of them are correct except for right here.
What?
The eight.
Yeah, so recording, Maddie's gonna just be so entertained today while she's home.
I'm sure you're
Probably
spending
sneezing
time
and
with
vomiting. She's probably like, I just hope that I get something entertaining to
Four,
watch.
yeah.
Right?
This is
This is
really
4 plus 2.
We are.
You probably accidentally did 4 times 2.
She's working on
There
this
you
at
go. Good
home.
job.
Maddie, you can do this at home too.
Can I just give?
No, you may not.
I know how to do it. It's just really annoying.
All right, real quick, the answers to A are 1, E prime would be 1, -3. F prime would be 5, -2. G prime would be 4, -8.
This is it.
For part B, no, we have a lot more. For part B, E prime would be 6, 6. F prime would be 10, 7. And G prime would be 9, 1.
Wait, okay, so how are we supposed to find these coordinates like online though? Like just give
What do you mean online?
Like on
So I wrote these because they're referring to this example.
Okay.
Okay, now we're going to look.
I need to start writing.
Oh, yeah. For example, too. Yep.
Do you need the book right now?
Nope, I don't need it. I only use it for the try things.
Okay, so try it too.
Yes, please. Okay, so what translation rule? Ooh, now we're going from looking at a translation to writing the rule. What translation rule maps STUV to STUV prime? Use one pair of corresponding vertices to determine the change. Okay, so, I mean, we could just count it on the coordinate plane, right? We could just go from S to S prime. Can we use any of them, or does it have to be a specific point? Is the rule the same for every single point going to its?
It's the same.
It will be the same, so we can use any point we want. They chose S, let's go with it. It's going to the left once.
Wait, I think I just noticed a mistake.
Huh?
Image.
It's going to,
It shows 6 on 7.
it shows 6 on 7. I don't know what you're
You
saying.
mean like
This is
no, on the up and down.
Why?
On 1.
on Y. Do you want to come up and tell me what you're talking about? I have no idea what you're talking about.
I just said like look where 6 is.
This?
Yeah.
Oh, really? 4, 5, 6, 7.
Master Popo.
Woo! Good job, Damascus!
Ice cream!
Ice cream?
Ice cream party!
Oh, if we had an ice cream party for every time we caught a mistake in the book, we
What if we
Oh, you sound
would get really sad real quick. Okay.
We have 5.
All right, listen. That is true. This 6 shouldn't be there. This is where the 6 should be. Thank you, Damascus. I don't think I would have ever noticed that. But you
Good job,
are very
Damascus.
observant, even all the way in the back. Good job.
We should
Okay.
have an ice cream party at the end of the quarter.
We definitely should,
I
just
guess
to,
so.
for all of our
Just to
our
accommodate the
toys.
algebra classes.
Yeah, okay, shh, all right, here we go. So, the S is moving to the left one, so that would be negative 1 on our X, and it's moving down 1, 2, 3, 4. So it's going down 4, so that would be a negative 4 on our Y. Now that's how we would do it, just counting the units, right? But we could also do it if they just give us, let's pretend for a second, and pretend that they did not give us this entire picture here, and they just gave us the starting point to the ending,
starting point to the
the
ending point?
pre-image point to the image point, okay? If they did that, technically, we would be finding the difference between our X values and our Y values, right? We would take the change in the horizontal direction, X, right? And we would have -6 minus -5. -6 minus -5, kill the cockroach, change the sign, and you get -1. So do you see how you can actually, without counting the units, you can take your 2 points. Let me see if it would work the other way too. -5 minus a -6. No, that would not be correct, so don't do that. Forget everything I just said. Okay, so you would have to subtract your image point, the prime point, minus your pre-image point to find the difference. Does that make sense?
Yeah.
And then same thing with the Y, subtract 2 minus 6, and you get -4, which is what we found when we counted. Yeah, it's easier to count when it's drawn out for you. If you ever were, taking your EOC and is asking this question, you want to count it, you just draw it on that graph paper. But you could also subtract it. All right, let's move on and see what fun example. Oh, okay, so here they show you a picture, so you can count it.
Just remember these 30s.
Oh, perfect, thank you. So go ahead and try this one. What translation rule maps point P, which is -3, 1, to its image, P prime, 2, 3. So point P is -3, 1. Try to do it without counting.
What?
Okay? Try to do it without counting. How about you do it without counting and then you can count to double check your answer?
Okay.
So what would we do? Here is, what would we do? What did we just do? We find the,
Wait.
without counting, what would we do? Oh, you know what? I need to back up. I need to back up because I didn't go over this part. This is really important. Once we find out that our rule is -1, -4, we actually have to write the translation rule. So it would be capital T and then the subscript parentheses would be -1, -4. That's how you write the translation rule, okay? So we're starting from this point and going to that point, but without counting, what would we do? Yeah.
Subtract -2 or 2 from -3.
2 from -3?
-3 minus 2. Oh wait, is it plus or minus? I'm confused. 2 minus -3.
Yes. So, yeah, that's what I just realized, is that you can go both ways. I know with slope, when you're finding like the slope, you can go either way as long as it's consistent, but that's because you just divide them in the end. This, you actually have to take your prime point
5 and 2.
and subtract, so you're basically going backwards.
Oh.
Okay, so you take your second point and then you subtract your first point. So you do 2 minus -3, 3 minus 1. All right.
Oh, wait, what?
So to find your translation rule,
Yeah. Well, like, which way are we going?
we're going from here, this is the starting point, this is where we're ending up. But without counting, how do we find it? Just by using the coordinate points.
Math sheet.
What? With math? Yes. Can you guys do it on your own? Okay. We have the answers. We can come around and check your answers for number 2.
You already did.
Raise your hand if you got it.
So close.
That's it. Remember your capital T. For what?
I don't wanna give it to you.
This was 6.2.
Do you want to use the summer class or something?
You just took it.
Wait, that's not the whole class is done.
Yeah, that's okay. So all we have to do to find how we got from P to P prime is find the difference of your x values and the difference of your y values, starting with
Do you understand it now?
your second point, your prime point. So you would subtract your x values kind of backwards. So minus negative. Yeah. Yeah.
Cool.
So you're trying you're seeing how you got from here to here by backtracking.
And we're talking what? And we're talking what?
Charity.
Just block out the A.
Number 2.
Everybody get it?
I mean, how would
Julian, are
write
you
it?
getting
What
this?
form would you write
You guys got it?
Hey.
Okay,
that? Yeah, perfect.
I'm gonna go over it really quickly. We're gonna take the difference of our x's, starting with the prime, 2 minus -3. Kill the cockroach, change the sign, and you get 5, so that would be our change in the x. And then 3 minus 1 is 2. So it would be a translation rule of 5, 2. You guys good? All right, so this is getting a little bit more complicated. Guys, I still have a lot to do today. If we don't get to those homework questions, come during lunch tomorrow, okay? And we'll just extend the due date. Okay. A composition of rigid motions. What is a composition? Boys and your friends, stop. A composition of rigid motions. What is a composition, like in general? Composition of a book? Yeah?
Like putting things in a specific way.
Okay.
Is it
Yeah.
like a makeup or something?
No, it's like putting things together.
Okay.
What's that?
Oh, no, yeah, that's like the science definition.
Oh, okay, what was the science definition?
I forgot what I said.
I said the makeup of stuff.
Yeah. That's
Oh,
what I said.
yes, okay, the makeup of something, it's composed of, yes. So that's totally accurate, because we're like, a composition is we're like putting things together. It is composed of something, right? So a composition of rigid motions is a transformation with 2 rigid motions in which the second one is performed on the image of the first one. All that means is you start with a pre-image, then you get an image, and then you get an image after that. There are gonna be 2 transformations. Oh, Maddie's here.
Maddie!
We were filming for you and we were saying hi to you that whole time. All right, you can end the video.
Bye-bye. Have a good leave.